So what are some of the different ways that we can represent motion visually? We're going to talk about today one of those ways and use that to also help understand the difference between terms like displacement, velocity, and acceleration, and how we can represent those again, like in a visual way. So let's imagine here you're doing a little physics experiment. You have a battery powered car. You're going to just like turn it on, set it on the ground, and it's going to go down a long straight hallway. So your job here is to figure out, is this car moving with constant speed? Is it speeding up or is it slowing down? And how are we going to do that? So if we, in physics, and this is like something that we're going to see a lot, if we can find out the relationship between position, so like the position of the object, per unit time, so what's the relationship between position and time, we're going to be able to pretty easily describe like speeding up versus slowing down versus constant speed. So let's imagine here you set a metronome. So that's the thing that's going to go like tick, tick, tick in regular intervals. Let's set that to 1 second. And for every tick that you hear, you're going to mark the position of the car with a sticky note. And by the end, you're going to have 10 sticky notes. We're going to take 10 seconds worth of data. And by the spacing of those sticky notes, we can see speeding up, constant speed, slowing down, what is it? So if we see that the spacing of those sticky notes is like pretty consistent, like the spacing between each set of sticky notes is about the same, what does that tell you about its motion? It tells you that it moves the same distance or has the same position change each second. So we think of that as being constant speed. So the same change of position per unit time. And if we give that direction, we call that velocity. So velocity is the rate of change in position. So we see that they're evenly spaced, same position change per unit time. This is constant velocity. But if you were to see it first, the spacing between those sticky notes is really small, but with each second, that spacing gets larger and larger and larger and larger. What does that tell you? That tells you that you have an increasing velocity or something that's speeding up, because at first it covers just like a little bit of position change, a little bit of displacement, but that displacement per unit time gets bigger and bigger. So we have a velocity that's increasing. If that distance starts off, or that spacing starts off larger and gets smaller and smaller and smaller, you have a larger displacement per unit time, a larger velocity at first, but then it gets smaller and smaller. You have a car that's slowing down. So if we translate this into a kind of diagram that we call a motion diagram, it's going to look like this. So we have dots that represent position. The spacing gives us an idea of how the velocity is changing over time, or if it's changing at all. And we can use this information to qualitatively describe the object's motion. You also notice here we have these arrows, and the arrows here that are like attached to the dots, they are there to represent the displacement for each 1 second time interval. All right, so that kind of connects us to velocity, right? So with velocity being the rate of change in position, like we already learned, that is a vector quantity. So that is something that has magnitude and direction. Displacement is the change in position. Like that's all that is. It's like how far and in which direction did the object move from starting to ending position. So velocity and displacement will always have the same sign and the same direction as each other. They both just indicate the direction that the object is moving in. But there actually is one more thing that we can add to these motion diagrams to, number one, just like give a little bit more information about motion. But the more important thing is this teaches you how to like very fully understand what signs, like positive or negative, to give displacement, velocity, and also acceleration. So we're going to get into acceleration now and how we can add that to our motion diagrams. So An object is accelerating if it has any kind of velocity change. So that's speeding up, slowing down, or changing direction. If the velocity is constant, the acceleration is zero. So let's look at this example here where we have an object that is speeding up. And to help you understand this, like especially if you're a numbers person, we'll put some numbers to this. Acceleration, like velocity and displacement, is a vector. So it has a magnitude and it has a direction. So that means we need to think like, does it have a positive or negative sign? In the diagram, we see here our little like displacement vector pointing to the right. So we're typically thinking of that as the positive x direction. So that means that we're going to give displacement a positive sign and we're going to give velocity a positive sign just based on the direction of motion. But this is an object that is accelerating. And the definition of acceleration is it is the rate of change in velocity. So we'll see a unit for acceleration that looks like meters per second per second. So how many meters per second is the velocity changing by each second? We usually more so write that as like meters per second squared though, just FYI. So if we look here and we see that the velocity starts out at 2 meters per second, and so in that like first 1 second interval, it's 2 meters per second on average, then it's 4 meters per second, then it's 6 meters per second, then it's 8 meters per second. From each interval to the next, the velocity change, delta V, is positive 2 meters per second. When we think about this as an acceleration, we think about it as, okay, this is a change in velocity, positive 2 meters per second, each second, so positive 2 meters per second squared. That's how we can describe our acceleration as a number. In terms of a direction, though, we're looking again at the sign of the change in velocity. So velocity changes by positive 2 meters per second each time. Our acceleration will have a positive sign as well. Okay, we can add that on our motion diagram as just like a little vector above or below, labeled as delta V, or you'll sometimes see it labeled as A, to indicate the direction of the change in velocity or acceleration, so that would point to the right. Let's look at another example here where we have an object that is slowing down. So in this diagram, you see the velocity vectors or the displacement vectors are getting shorter over time. So that indicates decreasing velocity. And again, let's put some numbers to this. So let's say we start at, we'll just go in the opposite direction. We'll start at, we have 10 meters per second, then 8 meters per second, then 6 and 4, so on and so forth. So from one velocity in the first interval to the next, we have a change in velocity of -2 meters per second. So overall, it's like we're seeing this change of -2 meters per second. So there's where we get our acceleration from, -2 meters per second squared. So now we see this negative sign attached to acceleration. So we can draw that as an arrow pointing to the left to indicate the negative direction of acceleration. So notice acceleration, the direction and sign of it, it has no correlation to the direction of motion itself. It's all about how velocity is changing. So let's look at a third example here. So now we have something that's moving to the left, indicated by the displacement vectors pointing to the left, but again, it's slowing down. So if we put numbers to this, so say we have like -8, then we have -7, then -6, then -5, so on and so forth. So now from each velocity to the next, we see this change per second of +1 meter per second per second. So this acceleration would be +1 meter per second squared. And you might be thinking to yourself like, wait a second, I thought that if something was slowing down, acceleration should be negative, right? Don't fall into that trap. That is such a common misconception. And if you get stuck there, like that will mess you up so many times. Don't do it. So we have to think about the sign of velocity compared to the sign of acceleration to get the idea right here with whether an object is speeding up or slowing down. So if you remember this rule right here, this will help you out a million times. So here's our rule. If you have an object that's speeding up, velocity and acceleration will have the same sign, whether that's both positive or both negative. if you have an object that's slowing down, that velocity and acceleration will have opposite signs, whether that's like velocity negative, acceleration positive, or velocity positive, acceleration negative. That's both like situations where you have an object that's slowing down. So make sure that you remember that rule and don't fall into the trap of like negative acceleration automatically meaning slowing down. You really have to look at both the signs of acceleration and velocity before you make that call. All right. So, in the next lesson, we are going to start to talk about some kinematics graphs. So, like position versus time, velocity versus time, acceleration versus time, and all that good stuff. So, make sure you remember that rule because that is going to help us out with graphing as well. And I'll see you next time.